Oh, stink, not what I wanted.
I got a
Oh yeah, it is.
$1,000 grant.
Here you go. Sam, can you give one of these to everybody? Shoop, 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 shoop.
That one, I liked it, but I didn't like to do it.
I know, but it's important. It's just hard to do.
Yeah. So, but I haven't gotten anything from FAFSA or like scholarships from UCLA. That was just the federal grant.
Oh,
Yeah.
Hi Joyce, sorry, I started recording so that you can hear what we're talking about. I am getting notes onto my iPad so we can go fast today.
Applied for a couple.
And then you have a practice test that Sam is putting back on the TA desk for you. Because our test is, we already talked about it, you just missed it. Our test is on Wednesday. Alright kiddos, so test on Wednesday, tomorrow is a work day, and today is a finish day. Sound good?
Yeah.
Alright, here we go. Hopefully I have your guys' notes uploaded. I think I do. Whoo! Finally. On the iPad so we can go fast. Joyce, we're starting late because I figured out that my dog got out a gate that was left open. But they found it.
good job.
They found it then?
Sounds like my cat.
I watched a documentary of puppies yesterday, you guys. It was so
There was some crazy races, and there was this one dog that was
The
going
green one's
crazy.
good on the, yeah.
Like he was like really far behind and he caught up and he won, and then he just started running around the thing. And there was little short feet.
They got it all wrong. Am I only going to take out the half, or am I like, if they got it wrong, they got it wrong?
Yeah, to see. I said, oh,
Like they didn't even show any good stuff.
cat will
Like take away the hard part. Then yeah.
let her in. Ski.
Alright, cool kids. Calculators out, we're gonna need them today. Georgie, what's up?
I'm trying to remember. Oh yeah, Twinkie, or not Twinkie, Toast. Apparently he peed on some item at the yard sale.
I
So,
feel like
Yeah,
you guys
so
could have
Zach-
sold it us.
so Zuck was whatchamacallit, like
Wait,
feeling
so they
guilty
saw
over
it?
the weekend. He was
Oh,
feeling
she
guilty.
saw it.
Yeah, she saw him and she totally forgot about it. She was gonna pay Project, but she forgot. And she was feeling guilty over the weekend because she forgot. So she's like, oh, I have my money. Yeah, it's so funny.
Oh my
So
word,
what
I
did
didn't
you
hear
get?
that story.
I don't know. She didn't tell me.
Alright, cool kids, here we go. On Friday, we realized we could memorize this whole table, or
Just not.
we could just find it if we need it, when we need it. So let's go ahead and figure out what we might need to find, when we need it, how we need it, etc. Calculators are out because we're going to need them. We're going to do as much practice today as possible. We did that on Friday, right? The cool, like, sector out thingamabob?
Yep.
Okay. We write this one down?
Not all this.
We should have gotten most of it. Endeavor number 30.
How many are left?
70.
Oh, huh.
Area of polar first. Technically? None? Unless we get some more in AP review. Nope, no, one more. One more, unless we get some in AP review. No, we're not going to have an endeavor quiz tomorrow just because we're probably going to need to be practicing with that practice test you guys have in front of you. P.S. It's already on your drive and the answer key is in the key folder. I think all worked out, if I remember right. We're not going to have an endeavor quiz, but the bonus on Wednesday's exam will be 1 or 2 endeavor cards from this section. Does that make sense? Maybe not the entire card, like I'll be asking something specific, like the vector one is the one I'm thinking of right now. There's a lot on that card, but I'll be asking 1 or 2 formulas, etc. So make sure, obviously, you need to know these formulas for Chapter 11 test, but that's how we're going to quiz you on them.
Misty, would you be able to, or would you have time to update them today?
I was trying to do it yesterday. We'll figure it out, yeah. I'll get it updated.
But you said the test quiz is on Wednesday? Right. Then I can wait till tomorrow night too.
Okay, I should update CalcBC today.
We're not doing anything special on Thursday, are we?
Class.
What about next Thursday?
You have the sample AP 2 days later.
Oh.
But, wait, you're gone for bio this Thursday. What's next Thursday?
Track meet, Occidental.
What time do you leave?
I have no idea.
Okay,
You know it's track, so probably like 6th period.
right. So you'll be here for this period.
Cool.
You guys are writing down some of the clues, and if you remember, you probably don't, but on Friday I was like, hey, these are good, and they're good things to think about, and they're little tricks that you might use, but it kind of just depends on the problem as to what you're going to do and when. So that's why we just need to get things ready and going. But graphing calculator's out because we're going to need to use them. I'm going to open up mine real fast up here, even though I have one down here for going quickly in the sense of things that you guys should know how to do already.
Oh shit.
Let's get to, wait a minute. What's the key important things we need to know about the formula?
It's 1/2. It's in between angles.
We have angular bounds, alpha and beta, and we have 1/2 r squared. How come? Because we're talking about the area of a sector. It's all behind the nice little calculator thing that's coming up. There we go. So we have angular bounds because we're going through angles and we're going out radiuses, and that's the long story short of the circular sectors. And we're not going into all the theory as to how this formula comes about and as to how the differential makes these infinitesimal lengthen, etc., because it's not quite as straightforward as I learned from Danny Regan and like the proofs class that she took in Cal Poly in the honors math program. But anyway, it's not quite as clear cut as the others, but long story short, you can still think of it as being similar with the integral having some sort of depth to this area of a sector, some sort of depth, some sort of thickness, and we're making them infinitesimally thin and accumulating them. Okay, so what would we do here? Find the area of the region in the plane enclosed by the cardioid. Hey, they tell us what it is. One of those little dimply ones with a little cuspy thing, but not an interloop. R equals 2 times 1 plus cosine theta. Don't worry, you guys, just get it down.
Alright. Yeah, just start plugging in. YOLO.
True, but what's the dilemma? What's a
Gotta
plug
find
in?
a bound, so we gotta set R equals to 0.
Maybe.
Maybe. I don't like technically.
What if we're just trying to think about how this function behaves?
Well, it's gotta be what you call it.
It's a
The
cosine.
cardioid has odd symmetry, right? No, it just depends on what it's oriented on.
It depends on the cosine. The cosine is, remember, the same in the first quadrant and the fourth quadrant, so it should have x-axis symmetry. Why am I doing pi over 3s from last week? Yeah. We'll just see what's going on in the first quadrant. Or actually, I guess the first 2 quadrants. Plugging in 0. Cosine is 1. 1 plus 1 is 2. 2 times 2 is 4, right? Pi over 3 is 1/2. 1/2, 3 halves. 3 halves is 3. Pi over 2, cosine is 0, so that's going to be 2. 2 pi over 3, we have negative 1/2, which will be 1/2, which will be 1. Pi will be negative 1, which will be 0. What on earth is going on?
Counting down from 4. It's like medium. 4, 3, 2, 1.
Something like that. Can I do it quickly? So we have our 0. Then we have our pi over 3, which is going to be 3. Then we have our pi over 2, which is going to be, oops, did I connect the 3 with the 4? I did. 3, 2. 2 pi over 3 is going to be 1, 0.
Oh, negative.
Do you see your cardioid?
Yeah.
Because that's going to do the little like, roughly.
So
So what are my bounds needing to be?
0 and 4. No, I don't know.
Remember, angles. It's all about angles. How long is it going to take for this to complete?
Pi. No, it'll be 2 pi because it goes from 4 to 0, and then it'll go from
Think,
0 to 4.
think for each angle. As I plug in, I'm going from 0 through all the angles. I'm going to cover this amount of space. That's what we put in the table. So how much is that going to cover? Half of it. So what do I need to do if I do want to use 0 to pi as my bounds?
Multiply by 2.
Multiply by 2. You can use the symmetry if you want. You can go from 0 to pi, but realize that's only half of the cycle. There is that symmetry above and below, so you could go ahead and just double it to get the whole thing.
Do we just say 0 to 2 pi?
Or you could do 0 to 2 pi. Either way is okay.
Would we have to graph it, or can we set it equal to 0 and solve it?
Well, here's the problem. It didn't start at 0. It started at 4. You know what I mean? So for a cardioid, it's only going to hit 0 once, and so I'm not sure it's going to help per se, unless you memorize or you have the idea down. Whenever it's of the form constant plus cosine theta, that's going to start removed and it's going to end at a 0, but we're going to have to then memorize it kind of for every shape. You know what I mean? So I'm trying to do it more of like a working knowledge than like a memorizing knowledge.
So you have to multiply it.
You guys squared the 2, right? The 2 gets squared. The 1/2 and the 2 cancel out. I can pull that 4 out. Why did I have you guys make an endeavor card from the power reducing formulas?
Because it helps, and that's the only way we can integrate.
Downtown. It's about to come in here.
It's cosine squared x. Oh wait, never mind.
I just foiled real quick. I pulled out the 4 and then 1 plus cosine theta squared will be 1 plus 2 cosine theta plus cosine squared theta.
You can tell me that you want us to do this by hand.
We're not going to do much by hand, but we'll do this one by hand.
Oh, sure.
So that you can see the power reducing formula at work, just in case they expect you to ever solve these by hand.
Yeah.
So then we can integrate the 1 easy. We can integrate the 2 cosine theta easy, and we end up with a is equal to, we could do 4, I'm just going to distribute in for sake of simplicity. So we're going to do 4 times theta plus 8, technically minus 8 sine theta. But then we have the dilemma of, don't worry, I'm doing everything from 0 to pi.
Cosine squared.
How do we integrate cosine squared? We don't.
Cosine squared.
We say, who does cosine squared equal?
1/2 times 1 plus cosine 2x.
Sorry, I was thinking of the formula where it's over 2, but you can do the 1/2.
Oh,
No, that works. 1 plus cosine 2 theta, right? The only difference for sine squared is it's 1 minus cosine 2 theta. And all of this, yes, of course, is from 0 to pi.
So it would help to like draw it out before setting your bounds.
Probably. Somehow you have to figure out what the rotation is. Sometimes it'll be 0 to 2 pi. Sometimes there's symmetry, you just go halfway. And sometimes it'll be 0 to pi or 0 to pi over 2 or 0 to 4 pi. You know what I mean? And that's only if we're talking about the entire area.
Negative sine 2 theta?
No, the integral of cosines.
I can reduce the 1/2 and 4
Yeah,
right to be 2. So we'll have
Oh,
2.
I'll go backwards.
So why do we have a negative 8 sine theta?
I don't know. I don't know.
You integrated to cosine theta.
Yeah, Miss, do you,
Should it be positive?
for the sine theta, the 8 sine theta, it should be cosine theta. The cosine backwards.
Oh, yeah. Thanks.
So it should be plus 2 sine.
Yeah.
But the 2 and the 1/2 cancel, right?
Yeah.
Ooh, we could do 4 theta and 2 theta is just 6 theta.
Yeah.
Go team. So plugging in pi, we get 6 times pi plus 8 times sine of pi.
Zero.
Mm-hmm. Plus sine of 2 pi.
Zero.
Minus 6 times 0 is just going to be 0. 8 sine of 0.
Zero.
Final answer?
Fine.
Dun-dun-dun-dun.
You know what I realized from chapel today? That it is possible for me to actually pick Manning's.
Oh wow.
And a cartoon. Okay, so
Or maybe feel like
now, how can things change besides just the equation and the graph and the bounds?
inside of the smaller loop of the
Woo!
That guy on me.
So we gotta find the area of everything and subtract, or is there
Now,
like an easier way?
question. With the limaçon, you guys know roughly how these go, right? Wait, why am I drawing it like this?
Cosine?
So it's gonna have x-axis symmetry.
Yes.
But we could graph it. Question, what is special about limacons with how the inner loop is formed?
Even symmetry.
Doesn't the inner loop start at 0 and end at 0?
Oh, snap.
Wait, isn't it plus 1?
Okay,
so
it equals
zero?
0, and it
Huh?
doesn't
Zero,
equal
we tell if it's plus 1.
Plus 1 is just going to expand
Wouldn't that be
the
the 2?
radius, but it will still equal 0, just at a different angle.
Okay.
But technically, if you still weren't sure, like I'm trying to show you a shortcut, like you could set equal to 0, and maybe that would be helpful. But couldn't we always just do the, okay, whatever, I don't know, this guy is somebody and I'm trying to figure out who he is? Yeah, sure. And we could go ahead and use our 0 and our pi over 3 and our 2 pi, nope, our pi over 2, and our 2 pi over 3, and our pi. Yes, that last one is probably the only one I'm going to solve by hand. When we plug and chug, cosine of 0 is 1, that'd be 3. Pi over 3 is 1/2, that'd be 2. Pi over 2 is 0?
1. 0.
Yeah, thank you, so then 1. 2 pi over 3 is negative 1/2, that'd be 0. Pi is going to be
Negative 1.
negative 2 plus 1 would be negative 1. So I go to graph my little dealio. I can have whoop, and I can have whoop, and I can have a 1 and a 2 and a 3, which is going to be the maximum value of this, by the way. 1 and a 2, and then 1 and a 2, and then a 1 and a 2.
It is plus 1.
Cosine of pi is negative 1. Negative 1 times negative, or negative 1 times 2 would be negative 2 plus 1 would be negative 1.
That's what I said.
Yeah, it's negative 1.
I put it up there.
Oh, never mind. I thought you were.
Okay. So then at 0 I have 3. At pi over 3, I have 2. At pi over 2, I have 1. At 2 pi over 3, I hit 0. And at pi, I'm at negative 1. So, we have this, right?
Yeah.
Now, question. As I go to solve, I have my alpha, I have my beta, and I have my r of theta squared, right? What are my bounds going to be, cool kids? If they're just asking for inside the smaller loop, am I going to start at 0? No. I don't want any of that. Where do I want to start?
2 pi over 3.
I want this area, right? However, that starts at 2 pi over 3. When does that end? Mm-hmm.
And we just multiply by 2.
I could go from 2 pi over 3 to pi, and then, yeah, just multiply by 2. Or, what's the other way I could go ahead and plug in my 2 cosine theta plus 1 quantity squared d theta? Question, what's another way of writing this? With different bounds. What's another way of writing this?
It would be 0 to 4.
Yeah, we don't want to do 0 because that's going to extend and get all this stuff that I don't want. That's not at all in my inner. How would this finish? Thinking symmetry. If this was 2 pi over 3. Mm-hmm. If that's 2 pi over 3 and this is pi, how would you complete it? You would need to go to 4 pi over 3 to go back to 0. Does that make sense? So if we were to find the zeros for the inner loop, knowing how an inner loop happens or occurs, we could have done 2 pi over 3 to 4 pi over 3. Why do you think most people would rather solve the first one instead?
It's the first pi.
The pi is easier to plug in than the 4 pi over 3.
Well, wouldn't you see that one first before you saw the other one? Like
Probably,
figured it
if you
first.
were graphing it, but if we used the trick of finding the zeros, we would have found 2 pi over 3 and 4 pi over 3. You know what I mean? Because it would have been when is cosine -1/2, which would have been second and third quadrants, the 60-degree angle.
Alright, Coesimos.
Does that make sense?
So we can just plug this into our calculator.
Yes. Question, do you have to be in polar mode? And the answer is no. You just have to be in radians and function mode and use x. Does that make sense? An integral is an integral is an integral. Solving it is just an antiderivative. It doesn't have to be polar or otherwise.
So it's fine if it doesn't have the little angle thing.
Exactly. Does that make
Data?
sense?
Yes. 1.5. Do you want the answer?
Sure.
1.54897379. However many of those you want.
I'll keep 3.
Okay, 1.5489.
1.54.
So 1.548 or 1.5.
Wait, hold on.
I got 0.544.
No, I didn't put a parentheses. Sorry.
Yeah, I'm getting 0.544 rounded.
Double checking.
0.5435. Sorry.
Cool. Alright, let's keep going. So we've seen that you could find the area of the whole thing, which we use symmetry to cut it in half. We could find the area of just part of a thing, like an inner loop, and we can do symmetry and just do a half again. What else could they ask us?
Oh no.
Hey, look, it's total area. You guys, on your own. Ready, set, go. I'm going to freeze the screen.
Oh, just another question.
Alright, so what'd you guys do?
Plugged in.
Okay, so you were trying to graph it first? Cool. So then when you plugged in, what were the values that you plugged in? Walk through the strategy with me.
0, pi over 6.
Cool. Why?
Because that gives you 0, 1, or 1/2.
Because it's fine. Good. And then we have pi over 2. How far did you guys keep going?
2 pi.
We went to pi first, and then there was only half of
I
it.
wasn't sure.
Yeah.
Weren't sure. Okay, what are the values you guys found?
0, 1/4, 1, 1/4, 0, 1/4, 1, 1/4, 0.
What kind of graph did that result in?
Infinity sign? Or eight?
I
think it's up.
forgot what it's called. Lemniscate.
Because you have 0. And then 1/4. And then 1/4 and 0. Approximately.
Yeah.
And then 1/4 and 1. 1/4 and then 0. Approximately. Cool, so how'd you guys plug into your area formula?
1/2 integral from 0 to 2 pi of sine squared thing and quantity squared.
Now, here's the party. What if you had to solve this integral? What would you have to do if you had sine to the 4th power?
1 minus.
Well,
Or would you multiply it out first?
I would do
No.
1/2. I do 1/2 1 minus cosine. Yeah, 2 theta squared. Yeah. that's what I
Okay.
did.
But the problem is when you do square that, what are you going to get?
That. Does it go to an infinite loop or something?
Not infinite.
What would it be before?
What would you have to do?
Then do it again.
Do it again.
Mm-hmm.
So you have to change your sine squared to be a cosine for your power reducing, then you would have to take your cosine squared and use power reducing again. That's just like a dot, 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 how you would solve the integral. Does that make sense? Cool. What if I gave you questions involving area between or inside both?
Right, right minus left.
Kinda, except we're doing polar.
like
So it's
that.
outer minus inner.
Oh.
Because we're doing radii. We're extending out along angle lines.
Still top minus bottom, right? 'Cause it's outer.
Kind of, but we can't say top bottom.
It would be like cylindrical
And for
shaft.
polar, they can easily switch, which is going to be exactly. So we have the idea of outer and inner. If you guys think about it, the outer will be the bigger one, right? And the inner will be the smaller. So we'd have outer minus inner. And that's why you guys see two different formulas, right? So we're going to have the outer being R1, the inner being R2. So you have to do formulas for both. And area inside both is usually found by addition. Now, area between, we're used to subtracting. Area inside both is going to be a little bit complicated. And it's all having to do with, if you guys can visualize, like I've been showing, starting from the pole and extending out to the different curves that you have, that is what that integral of 1/2 r squared of theta d theta denotes. Starting from the pole, extending out to the radiuses of the function that you're plugging in. Intersections, setting the two equal to each other. We did that with rectangular equations, with f of x's and g of x's. But here's the long story short. We have yet to get to probably the most complicated ones that require a lot of visualization.
That's the gangster.
I would like to have the test on Thursday, but that's a problem for Gerardo, who's going to be gone all day.
Friday?
Thursday.
But what if we did it Friday? That work?
I don't know what we would do for Thursday, but I think we can totally finish this tomorrow. And we are going to have less time to then do our AP review.
What the-
What if we start
Um,
AP review on Thursday? What if we start AP review on Thursday?
And you cripple me.
We'll cripple you
watch
either
the
way.
video.
Oh.
Yeah, you're missing a day. You can't just sit there and do that.
I can always face
Gerardo, are you okay if we just take the test on Thursday and then you take it during period 7 or after school or something on Friday? Or you could do it while we start.
Because I have no 7th period. I have my 7th period personal finance.
Okay, how about after school on Friday?
Just take it one day.
You can take it Wednesday if you really want to.
We're doing lunch.
Is this like this
Okay.
was the least?
We'll just do
common?
during class on Friday then. So you're taking it during class on Friday. If you want to bring headphones, you may. That way you don't have to worry about trying to do after school.
Is after school harder because there's people in here?
Probably. And it's a Friday. So we'll do during class on Friday.
Okay.
Because long story short, kiddos, is, for examples, well, these following ones, I do have a couple FRQs, and so it'd be great if we could cover. I thought we'd have to skip the FRQs, but it'd be better. You'd be better prepared if we're able to finish them.
Okay.
Now, Gerardo, depending on, technically tomorrow is Tuesday, so if we get these examples done in class tomorrow, you can finish homework on Tuesday night, or maybe even before you get home or something like that.
Yeah.
And you work through the review, and if you're like, I can be ready Wednesday, then we can always do it Wednesday in class when we're reviewing, working on the chapter test. But it'd probably be smartest, I think, for you to take it in class on Friday.
Yeah, that's the best.
So chapter test will be due the day of the test, so we're going to be working on it on Wednesday.
Okay. Can you go back to the number, the area between them?
Yeah.
Alright, so it says from alpha to beta, I think that's what it is, but on both of them, does that mean they're the same bound? Or I thought you said.
Not necessarily.
So should we have?
So we'll probably change it to 2 other Greek letters, and I don't know which ones I want to use.
Why can't we do A to B again? Like, I don't.
Because we're trying to denote that they're angular bounds, and since they're angular bounds, they're trying to use Greek letters just to remind you. But we could do A, B, C, D, just that's not how we normally talk about angles. Does that make sense?